And I'm back. Okay, so I had confused myself because there's two ways to do this, and I wasn't sure which one was easier or which way the book did it. So I quickly saw what the book did. Blah, blah, blah. Excuses, excuses, excuses. Okay, so where were we? We were right here. So f of g of 1, so let's write it as f of g of 1. Okay. And then g of 1, maybe you want to do g of 1 off to the side, right? G of 1, that's easy. Just plug 1 into this function. 4 times 1 minus 1. 4 minus 1, that's 3. So g of 1 is 3. Okay, let's substitute it back in. So that's just f of 3. Oh, okay, we know how to do this. So let's just plug 3 in there. So that's just 5 times 3 squared minus 1. 5 times 9 minus 1, 45 minus 1, 44. Okay, so that was easy. 10, f of g, g of f, f of f. Okay, so let's just jump to C, 10c. So f of g, easy, g of f, easy. And then it's still easy, but they might look weird. They're like, in part C, they say, oh, what about f of 2? What? No big deal. Just do it like we did here. So that's f of 2. Okay. So what is f of 2? Well, let me do that off to the side. F of 2 is 5, 2 squared minus 1. That's 5 times 4 minus 1, 20 minus 1. That's 19. So f of 2 is 19. Okay, well, let's substitute that in. So f of 19. Okay. Oh, function f, 19. Okay, I know what to do. I just plug it into, plug 19 in there. So that's 5 times 19 squared minus 1. That's 5 times 19 squared. Oh my gosh, am I supposed to know what that is? 19 squared, 381? I don't know. 361, r minus 1 times 5, enter. So that should give us 1805 minus 1, 1804. Okay. So we skipped part B because it's just g of f. If you could do f of g, you could do g of f. F of f, it's easy, right? You just might have thought it looked weird. G of g, whatever. It's all easy. So that wasn't bad. Okay, then moving on. Number 14. 14 represents a function. Okay, so 14, they give us some points. 9, negative 3, 4, negative 2, 1, negative 1, 0, 0. It gives a lot of points. 1, 1, 4, 2, 9, 3. And then they put inside the curly bracket. Okay, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I had graph paper, that'd be a lot cooler. Okay, so let's just plot these points. 9, negative 3, over 9, down 3. 4, negative 2, over 4, down 2. 1, negative 1, over 1, down 1. 0, 0. 1, 1. Over 4, up 2. Over 9, up 3. Okay, so here's our picture. In the following exercise, determine if the set of ordered pairs represents a function, and if so, is the function 1 to 1. Okay, so let's just write down this idea. Here's the idea. Functions pass the vertical line test. So, can you draw a vertical line and hit 2 points anywhere? Can you draw a vertical line and hit 2 points? Yeah, there I hit 2 points. There I hit 2 points. There I hit 2 points. It only needed to happen once. So since I can draw a line, a vertical line, and hit 2 points, not a function. So that's the vertical line test. So in order to be a function, you must pass the vertical line test. So it's kind of a weird definition. So if you can't hit 2 points with a line, then it would be a function. And so the extra idea, so this is not a function, and then they even ask, is it one-to-one? So a one-to-one function passes the vertical and horizontal line test. Bad font. Okay. So, quick example. Just going to make something up. 3 dots like that. Does it pass the vertical line test? Can you draw a vertical line and hit 2 dots? No. Cool. It's a function. Can you draw a horizontal line and hit 2 dots? No. Oh, cool. Then now that it's a function, and so first you do the vertical, then you do the horizontal. Okay, so function, and then if it passes horizontal also, we can say it is one-to-one. This will all make sense later, but it's just sort of vocab for now. So function, yes. One-to-one function, yes. This horrible picture of 3 dots. Okay. So then they give us different things. So part B, what is that? 17B? Okay, I'll do 18A. 18A, so instead of dots, they sort of go to pictures. So in 18A, they give us a sideways parabola. That little sort of U thing is called a parabola. Okay, so does this pass the vertical line test? No, because if I draw a line, I hit it, a vertical line, I hit it in 2 spots. Well, what if I drew the vertical line there? Yeah, you hit it in 2 spots. So is there a place where you can draw a vertical line and hit it in more than 1 spot? Yes, then it is not a function. So, not a function. Is it a one-to-one function? I'm not even going to bother wasting my time. It's not even a function, so how could it be one-to-one? Okay, cool. Let's try 20. Oh, was there a part B for 18? 18B. There was B. Then I don't have to do 20. Okay. 18B. There's a weird looking picture. It's kind of like a S looking thingy. Like that. Okay. Does it pass the vertical line test? Can you draw a vertical line and hit that squiggly in more than 1 spot? Nope. Cool. So 18B is a function because it passes the vertical line test. Okay, now that we know it's a function, if it also passes the horizontal line test, then we say it's a one-to-one function. Can you draw a horizontal line and make it hit the picture, the squiggly line, in more than 1 spot? Nope. So it is also a, so it's a function, yes, and it's also a one-to-one function. Hey, these problems are pretty easy. Yes. Okay. The inverse, find the inverse, determine the domain and range of the inverse. Silly problem. 22. They give us some ordered pairs. 6, 2, 9, 5, 12, 8, 15, 11. The domain, range, and inverse. Okay. Remember, these all just consist of an x and a y, right? So there's x and there's y, and that's just the domain and the range. Alphabetical order. X comes before y, D comes before I. So x is just the domain, y is just the range. So our domain is, what are the x values? 6, 9, 12, 15. Okay. And the range. Oh, you mean what are my y values? 2, 5, 8, Coincidentally, they're in order. Traditionally, we put them in order. Just they happen to be in order. So if they're not in order, you can put them in order. If a number is repeated, right, if it was 15 and then there's another 15, you don't really need to write it again. Oh, the inverse now. So now the inverse is, all you do with an inverse is you switch x and y. Okay. So 6, 2, that becomes 2, 6. 9, 5, that becomes 5, 9. Hey, this is easy. Yeah, I know. 8, 12. 11, 15. Ta-da! Okay, 28. Need a new piece of paper for 28. 28, they give us a weird picture, and then they want us to draw the inverse. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So they give us the point 4, negative 4, or what's negative 4, negative 4. Give it 1. 2, 4. That one is 0, 2. Negative 3, 1. And negative 4, negative 4. Okay. So 2, 4. Remember to get the, we're going to graph the inverse. So the inverse, 2, 4, remember the inverse, you just switch them, it goes to 4, 2. So over 4 up 2. 4, 2. 0, 2 goes to 2, 0. So over 2 up 0. Negative 3, 1 goes to 1, negative 3. 1, negative 3. And then, so it's 1, negative 3. And then negative 4, 4 goes to, switch them, oh, negative 4, negative 4, same thing. Okay. So, same dot. So in black ink, the original problem looked like this, and now our inverse looks like this. So if you switch x and y in a picture, all you're doing is you're reflecting across the diagonal. Oh, mirror image. Boop, beep, pop. So that's what an inverse is, graphically speaking. You're just taking a picture and you're pretending that diagonal across there, that diagonal across the quadrants, is like a mirror. So it's just flipping it. Or it's a rotisserie, maybe, if you prefer. Okay. Because all you're doing is switching the x and the y. Determine whether or not the given functions are inverses. Okay. Okay, do some work on here. Still got some work. So, an inverse, 32. F of G, R. F of G of x equals x. G of f of x equals x. So you have two functions, say f of x and g of x. This is a weird idea. The math isn't too bad, but the idea is a little weird. So you have a function f, it does something. You have a function g, it does something. What if whatever this does, this undoes it? Or whatever this does, this undoes it? They undo each other. They're inverses. So in mathematics, when you say something undoes something or to do something backwards, it's an inverse. So if I do f of g of x, it should just bring me back to where I started. Or if I do g of f of x, it should just bring me back to where I started. Okay, so let's just try 32. So that's the idea. So 32, they give us f of x is x plus 8, and g of x is x minus 8. Okay, so do those ideas undo each other? Hey, add 8 to something. Hey, subtract 8 from something. Seems like it. So let's just try f of g of x. that's going to be f of g of x is x minus 8. And then if I were to plug x minus 8 into the function, that function f, that's going to be x minus 8 plus 8, which equals x. Let's try g of f of x. That's g of f of x happens to be x plus 8. And what does function g do? Whatever you give it, it subtracts 8. So we give it x plus 8, so it returns x plus 8, and then it subtracts 8, and it returns x. So f of g of x equal to x, g of f of x equals x. So these guys are, in fact, inverses of each other. And then to oversimplify things, what does function f do? It says whatever you give it, add 8. What does function g do? Whatever you give it, subtract 8. So intuitively, you're like, oh yeah, obviously those undo each other. You didn't need to do all that. Okay, but we did it mathematically anyways. Whew. So you have to do both. You have to do f of g of x and g of f of x. Find the inverse. Okay, now it's getting real. Not really. We'll need a new piece of paper for this, darn it. There's some steps. There's some examples up above if you read the chapter. So 40. F of x equals x plus 17. Step number 1. So if you go up and read, the rules are the same. Step number 1 we call f of x y. Y is equal to x plus 17. So step number 1, call f of x y. Step number 2, hopefully you're taking notes, write that down. Step number 1, call f of x y. Step number 2, switch x and y. Step number 3, solve for y. Solve for y, okay. Subtract 17, subtract 17. Y is x minus 17. Let me write it one more time. Put the y, put a switch and it looks prettier. So you might do your math a little differently, but we both get that. And then the last step is call y f inverse. F with a little minus 1, f to the minus 1 of x equals x minus 17. Okay. Just want to make sure they use that notation. Let me scroll up really quickly. They do. Yay. Okay. So, horrible notation. But what are you going to do? So, f to the minus 1 of x is inverse. Is f inverse, or the inverse function of f. So this f, we just call this f inverse, the inverse function of f of x, f inverse. So don't go thinking, oh, to the minus 1 power, do I bring it downstairs? You don't do that. You're like, but that makes sense, and I memorized that that's what you do. Yeah, I know, but then some mathematicians introduced this weird notation and it stuck and it messed everything up, but okay, just memorize this is f inverse. Very confusing. That's 40. So this is sort of a big game in math, finding the inverse of a function. So that's why we were doing all these problems up until this point. Let's try something better. 46. F of x equals 7x minus 1. Step number 1, call f of x y. Y is equal to 7x minus 1. Step number 2, switch x and y. X equals 7y minus 1. Step number 3, solve for y. Okay, let me add 1 to both sides. Get y alone. 7. So y is equal to x plus 1 over 7. Final step, call y f inverse. Okay, f inverse of x is equal to x plus 1 over 7. Boom. Making sense? Can you even read that? X plus 1 over 7. Okay. That was 46. Do they get crazy? I don't know. Let's try 56. How crazy can it get? 56. F of x equals equals the square root of x plus 8. And then they kind of put some little parameters off to the side that like x is greater than or equal to negative 8. They're just making sure that you're not taking square roots of negatives. So just kind of ignore that extra stuff that they wrote. Just say thank you, book. Okay. So now, let's see. F of x. So then we'd say y. So we call f of x y. X plus 8. And then we switch x and y. X equals y, square root of y plus 8. And then we need to solve for y. Ooh, remember we learned how to square both sides? That'll get rid of that square root. Square both sides. X squared equals y plus 8. Trying to get y alone, so let's subtract 8. Subtract 8. So x squared minus 8 is y. Write it one more time. Like that. And then last step, call y f inverse. F inverse of x equals x squared minus 8.